All right, so welcome to Unit 7, which is going to seem very similar to what we just did, because I guess the rest of the year is pretty much just inference and different ways to run those like hypothesis tests. Last unit was categorical data and it was proportions. Unit 7 is quantitative data, and now we're looking at means. So instead of looking with p hat like we did the last unit, now we're looking at what happens with like x bar, okay? All right. And remember the parameter for means. So remember for p hat, our parameter for the population was just regular p. When we're looking at x bar, which is a sample mean, its parameter is the population mean, which is mu. Okay. So just a couple things to review before we move on to the actual big part of this lesson. Another review about the different conditions we have to check. We have to check for approximately normal shape. And this one is the one that's going to be a little bit different, okay? Because we have the central limit theorem to work with, and so that does change things up. So remember, when n is greater than 30, we don't have to do any extra checks. That just tells us that the central limit theorem tells us that our sample is going to be approximately normal, okay? But if we have an n less than 30, we have to check to see if the population is normally distributed, and that will be given to us in the problem somewhere. Okay, because if the population is normally distributed, then we can reasonably assume that the sampling distribution will be approximately normal. Okay, all right. So then once again, our center. Okay, we're looking at the mu of x bar is going to be equal to the mu. So the mean of x bar is going to be equal to the population parameter. Okay, and the two conditions we have to worry about here is our sample randomly selected, or are we using random assignment in an experiment? Okay, so those are the two things we got to check. Okay, and then spread. So our standard deviation is where things are going to get very different with means than it was before. But just as a quick recall, standard deviation of our sample mean is equal to the standard deviation of the population over the square root of our sample size. Okay, the condition we have to check here is, of course, the 10% condition has to be less than our sample has to be less than 10% of our population. Okay, so that all covered. Now let's recall a little bit of review about confidence intervals. Okay, so this is what we did at the start of last unit, was where we had our why do we have to use them to estimate an unknown parameter. Okay, so in the last unit we checked about proportions and we ran through all those tests. We had a confidence interval that told us, how confident we were that our true population proportion is in between two values. And to calculate our confidence interval, we had this. We had our statistic, which in the last unit was our p hat, but in this unit it's going to be our x bar, okay, plus minus our critical value, okay, which was of course the z star, which we found using inverse norm, okay, and then this times the standard deviation or the standard error of whatever statistic we're working with, okay. All right, so this is where things start getting a little different. Remember, I've talked several times about how this right here is what you have on your formula sheet for the AP test, okay? But you have to remember how this changes for each parameter, okay? So last unit was proportion, so it had its formula, and then this unit's all about mean, so it has its formula, okay, which looks a little bit like this: x bar plus minus our z, okay? And then we have our standard deviation or standard error for our means, which was standard deviation of the population over the square root of n. Okay, and of course we know z star is the critical value with c% of the area lying between negative z star and positive z star. Okay. All right, I'm gonna go ahead and end the video there. That's a quick review from stuff we should know, and then we're gonna move on to an example.